All right, so we are looking at lesson 5 today. We're going to do vector equations and forces in equilibrium. So hopefully after this lesson, you'll understand how vector equations and forces in equilibrium work. I really like these. Best real life application I can think of real quick is dealing with tug of war. If the middle flag doesn't move, that means that the two teams are pulling at the same amount. And so that would be an example of forces in equilibrium, where that middle flag isn't moving because both of the teams are pulling the same force, which is rarely happening for very long. All right, so there are two ways that you can set up your vector equations. You can either say 72 equals T2 sine of 55 or 72 minus T2 sine of 55 equals 0. The solution to both is going to be the same, but you can set them up either way. It doesn't matter to me. So in this book, we are going to concentrate on problems that have force components in the x direction and force components in the y direction. If the sum of the vector forces in the x direction is 0 and the sum of the vector forces in the y direction is 0, then that's when it is in equilibrium. And so that's what we're going to be looking for, making the x equal 0 and making the y's equal 0. So here we go. We've got three forces here. One of them is T1, one of them is T2, and the other one is 72 newtons. And so we want to find the value of T1 and T2. So we have to break it down into our x components and our y components. So the x components are T1 and then this part here of T2. The y components are 72 and this part of your T2. So what we have to do is figure out this x value and this y value. And that's found using sine and cosine. So the x, we would do cosine of 55 equals x over T2. And so our x value is going to be whatever T2 is, cosine of 55. For the y, it would be sine of 55 equals y over T2. And so your y value would be T2, I left off a 5 over here, sine of 55. Okay, so that's what these two would be. So our two x's are this T2 cosine of 55 and T1. So we have to make them equal each other so that there's no movement. So T1 is going to equal T2 cosine of 55. In the y value directions, we have 72 and we have y. So 72 has to equal T2 sine of 55. And so from here, we're going to divide by the sine of 55 to solve for a T2. And so if you use your calculator, T2 should equal, it's 87.895, and we have 4 sig figs in the only number they gave us. So T2 would be 87.90, and forces are in newtons. So that would be your T2. Okay, now we need to find our T1. Well, we're just going to plug T2 in right there. So I'm going to take what my calculator gave me and then multiply it by cosine of 55. And if you do that, you should get 50.41, and that's because we're only going to 4 significant digits. And so that would be your answer. Okay? So that's how forces in equilibrium work. I actually really like these. I think they're fun to do. You probably just laughed, but I think these are really fun once you get the hang of it. You just have to figure out your forces in your x direction and your forces in your y direction and make sure that they equal out. Okay, so now we're going to look at this one. We again have three forces. We have 350s pulling down, and then we have a T1 and a T2. So this one's going to be a little bit more work because neither T1 nor T2 is directly vertical or horizontal. So we're going to split it into triangles. On both of these. And instead of writing my equations, I'm going to put them right here. So this is going to be T1 cosine of 20. And this one is going to be T1 sine of 20. Over here, this is going to be T2 cosine of 40. And then this one is going to be T2 sine of 40. Okay, so that's what you're going to start with. Now, we need to make our two equations. So one of them is the x direction, which there are only two. T1 cosine of 20 have to equal T2 cosine of 40. Okay, which we can't solve that equation for either one because we have two variables. Okay, for the y's, we have this one and the 350. Now the 350 is going down, the other two are pulling up. So T1 sine of 20 plus T2 sine of 40 are going to have to balance with 350. And so these are the two equations that we have. Now again, we can't solve for a variable because we have two variables in our equation. So what we're going to have to do is to solve for one variable and plug it into the other one. So I'm going to take this equation and divide by cosine of 20 to solve for my T1. So that's what T1 will equal. T2 cosine of 20 over cosine of 40 over cosine of 20. So we have, instead of T1, T2 cosine of 40 over cosine of 20, and then times sine of 20, plus T2 sine of 40 equals 350. So from here, we need to factor out the T2. And so we're going to have cosine of 40 times sine of 20 all over cosine of 20 plus sine of 40, and that's going to equal 350. And so we need to figure out what this number on the left side is. So I'm going to use my calculator on the computer to show you what to do. So we're going to do cosine of 40 and then sine of 20 There we go. Okay, and then hit enter. And then you're going to divide by cosine of 20. And then you're going to add sine of 40. Whoops. And I should have checked. I am in degrees. Okay. So that's what I get. Cosine of 40 times sine of 20 divided by cosine of 20 plus sine of 40. So all of that goes over here, 0.92. So T2 times 0.92 equals 350. And so then we're going to do 350 divided by this whole decimal up here. And you should get about 379. Now, how many sig figs do we have in our problem? The only number they gave us was 350, and there are 3 sig figs there. So 379.7 is going to round to 380. So if you look, T2 is going to be 380, and we have to have 3 significant figures. So we have to put a bar over the 0. And then the units on forces are newtons. Okay? Now for T1. All we have to do is come back up here and plug it in, because T1 equals T2 times cosine of 40 divided by cosine of 20. So take that number, multiply by cosine of 40, and then make sure to close your parentheses and divide by cosine of 20. And you should get 309.5, which if you do sig figs, that'll just be 309. Wait, did I round that correctly? No, not 309. 310. And then with a bar over it, newtons. And so that would be your answer. So on these, you can show more work. Your work mainly is for yourself though. So you can show as much work or as little work as you want, but it'll be hard for someone else to help you if you don't have a lot of work to show them what you did. So you are going to be using the calculator a good bit, so you definitely need to have a calculator to use at home. I would recommend one besides your phone, since you can't use your phone in class, just so that you are able to use the same tool consistently. So that's how you do forces in equilibrium. Again, I really like them. They're not going away. So you definitely have to practice them if you are having trouble. For your homework, you need to do numbers 1 through 20 so that we can go over your questions you have tomorrow.